Okay, greetings, welcome back everyone. It's nice to see everyone back. Still lots of people coming to lecture, that's good. So I want to talk a little bit more about level sets, contour maps, and then we're going to head into limits in continuity and partial derivatives. So we're going to talk a little bit more about contours and then head into that stuff. Okay. So this issue about contours is often very difficult for people in this class. I want to do some more examples of it. We'll sketch what happens for the function x times y. Right, so we want to sketch 3 level curves of x times y and label a point on each curve. So we're free to pick which level curves we want to draw, right? This doesn't specify which level curves. So we'll take, let's say, a -1, so we'll sketch -1, 1, and 2. Okay, now when we sketch level curves, we set the output of our function equal to that constant that we've got. So here we've got x times y is 2. We can explicitly solve for y in terms of x. And then we can plot that curve. Pick a point on there. We're free to choose many different points. Pick one that's nice to calculate with. We'll pick when x is equal to 1. So far so good. Here for k equals 1. Over x. So we're getting a very similar level curve, but now all of our x's all of our y values are slightly smaller. That would contain the point 1, 1. We get at -1. And notice we can get that level curve by flipping everything on k equals 1 level curve across the x-axis. gives us some kind of sense of what the function looks like. Right, we get the sense that as k increases, these level curves will go up. So fill it in. Okay. Thoughts there? Yes?
Should that be one negative one?
Yes, 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 perfect. Yes, that should be 1, negative 1. Thank you. Other thoughts or comments there? Yes?
So you decided not to do k equal to 0, but if you did, would it be a straight line, but like I'll hold it x equal to 0?
Yeah, let's add in k equals 0. That's a cool additional thing to plot. Right, so there we get that x times y should be 0. So that means either x is 0 or y is 0. So or 2, y 2. One of these guys has to be 0. So when we draw this level curve, we get exactly the axes. Right, there's our y equals 0 curve. And then our x equals 0. Yes?
So if we're asked to sketch any, sketch 3 level curves, so do we choose any k or?
Yeah, you can pick any k, and you can pick k that are convenient to draw. Just don't pick k equals pi. It's something hard to draw. Other thoughts there, comments there? Okay, yeah, so sketching level curves, yeah, often you are able to isolate for y and then sketch the thing. There's one other aspect of this sort of just general notions about two variable functions that I want to talk about, which is the notion of domain. So the domain of a two-variable function is all of the input values for which the function is defined. So these sort of common issues that come up in functions being defined or undefined are things like square roots of negative numbers, lns of negative numbers. Square roots of negative numbers aren't defined in this course, at least.
They're the complex. The complex solution.
Yeah. Complex numbers aren't defined. Logarithms of negative numbers, same issue. Divisions by 0. Right, if you divide by 0, your paper bursts into flames. Terrible. Okay, so these are the sorts of issues that we want to look out for when we're trying to find the domain of something.
Sketch the domain.
the domain is a subset of the plane, right? So you can draw it. One of the things I love about this course is that there's a lot of drawing involved. I like things that you can sort of visualize and see. So there'll be lots of sketch such and such. Sketch the domain. One of this guy. So you'll notice that there are certain input values this is not going to be defined for. Right? If I plug in x is 100, y is 100, I'll get 4 and a big negative number. Right? So we're not going to be defined at 100, 100. And the question is, where are we defined? So we've got this issue about lawns of negative numbers, lawns of 0 and negative numbers. So in order for this to be defined, we need the stuff inside to be positive. Greater than 0, yes, perfect. Right. For a lawn to be defined. So we get these guys add up to something less than 4. Okay, and now when we sketch this, we're going to get all of the points
Inside a circle of radius 2.
Yeah, look at this guy. Inside a circle of radius 2. Nice. So I've drawn a filled-in circle, or like a solid circle. If we want those points on the boundary to be excluded, draw it as a dashed circle.
Like we cannot be on the line itself, right?
Yeah,
Because it will be 0 and ln 0 doesn't make sense.
Perfect. Yeah, if we're exactly on that boundary, right, if we're at a point like 0, 2, then we get ln 0, which is not defined. Just have a look at what that looks like.
So like for this kind of a thing, if the question says what is the domain, so leaving here is perfectly fine.
Right, so okay, so the question was, is this a nice final answer, right? Could we finish the question here? And I think for the question of sketch the domain, this is a good sketch, and this is done. Okay, so what does this thing really look like? Whoa, weird. Right, so we see that at those points, 2, 0, 0, 2, our thing has like a vertical asymptote of some kind.
It's like all of the points.
So we get that same kind of thing, and notice that if we look at the cylinder, that cylinder of an appropriate radius, we see that our graph is sort of like, has that cylinder as a vertical asymptote, right? It never touches the blue region. Zoom in. Computer, hands. Maybe not. Yeah, the blue region never touches the red cylinder. This diagram. Right, it gets quite close, but never touches. Okay, so that's sort of the 3D sketch of what the thing is, but I would say that this sketch with the dotted boundary is quite nice. Other thoughts there, questions there?
Does it always?
So the inside is shaded in?
Yes, yeah, inside shaded in. Yeah.
It doesn't always have to be circle, right?
Domain?
Yeah.
Oh, I mean, it wouldn't necessarily be a circle. It depends on the function. Yeah.
Like if it was x minus y squared, then we still have some constraint.
Okay, so the question was, does it always have to be a circle? Fair enough, we've seen one example, it's a circle. Try out the following.